Okay, in our last session, we discussed in detail about the RBAC, and we did 4 sessions for the RBAC. So we discussed in detail how the RBAC is working and how to create role-based access policies for the service account. What is the purpose of service account? The account to connect with the Kubernetes cluster for the humans, and then the concept of context for a single cluster multi-user or multi-cluster multi-user context. So in today's session, we have to discuss about a new topic that is about the storage class. So far, what we understand about the persistent volume, we did a detailed session about the persistent volume and persistent volume claim, and on the back end we use the NFS. So if I give you again an idea of how this whole thing is working so far, we did. So just like this is our cluster. Within our cluster, we set up some pods, and a pod was basically pointing to PVC, persistent volume claim, and persistent volume claim was pointing to persistent volume. Okay, so persistent volume can be the persistent volume can point to different storages. It can be inside the cluster as a storage. Okay, and it can be outside the cluster as a storage. So this thing like this is host path. So we set up this one too, and we also set up the persistent volume that was pointing outside the cluster. That was our NFS storage. So we did like this too. So we provision an NFS server outside the cluster, and PV persistent volume was pointing to outside NFS storage. So this was the complete flow where our pod can access the persistent volume outside the cluster or within the cluster. And there are other type of local storages we discussed, the host path, the empty volume, and directly persistent volume claim can directly point to NFS2 without persistent volume. We did these all concepts in detail if you look the previous videos about persistent volume for the pod. So this was the whole flow to provision the persistent volume. But in professional life, it is the persistent volume claim is created by by developers or different users. You will provision for this cluster using RBAC. And those users will create the PVC. And PVC will be in pending state if persistent volume PV is not available. So we need to provision the enough number of persistent volume for all the PVCs. So if there are no free persistent volume, it will be in pending state. So the concept of storage class is to provision the persistent volume automatically whenever a persistent volume claim demand come to for some pod for some persistent storage. So whenever someone will create a persistent volume claim, so in persistent volume claim, we will define some storage class, and that storage class will automatically provision storage from outside the cluster. That storage class can be NFS based or any external storage. So normally on-prem Kubernetes clusters are using NFS-based storage, but when you are working in the cloud, so I will show you if you go to the Kubernetes documentation, type here storage class. So you can see the storage class definition. So storage class provide a way for administration to describe the classes of the storage they offer. Different classes might map to a quality of service level or the backup policies or to arbitrary policy determined by the cluster administrator. Kubernetes itself is unopinionated about what class represent. So it's up to you what type of storage class you want to provision. Okay, so storage classes can be associated with different technologies that can provide the storage. Uh, just like in the cloud, we can provision different type of storages. We can provision iSCSI, we can provision fiber channel based, SAF storage, NFS, block storage based storages, or cloud object storage, just like S3. So these all storages we can provision by using storage classes. Manually provisioning of persistent volume is a very difficult job. So storage class will do the resource setup on cloud and attachment of those resources to the cluster, and everything will be done by the storage class. So if you are working on some VMware based vCenter based solution, then vSphere volumes you can use, and those volumes you can provision by the storage class that can pull the storage from the vSphere data store. So if we go down, we can see storage class parameter, the AWS Elastic Block storage we can provision, NFS storage we can provision, vSphere. CSI we discussed in detail when we did our last session on persistent volume and persistent volume claim. So CSI actually are the drivers that will help to automatically set up the storage in cloud, and then the attachment of those storages with the cluster. So if we go down, we can see you just read this whole documentation. You can see what type of cloud storages are available, and when you spin up your cloud-based Kubernetes cluster, how these storages will work. But today, right now, so far, we have not done anything on cloud. We did everything on-prem. So on-prem, we set up the NFS-based storage. So for the NFS-based storage, I have an NFS server, and that NFS server is so far suspended, and this is my Kubernetes cluster up and running. So let me just take a look, kubectl get nodes. Okay, my cluster is up. And so today we have to set up the storage class. In last session, we did manual setup of persistent volume and persistent volume claim. But now we are going to set up a storage class that will automatically provision the storage in NFS whenever we will generate a demand of persistent volume claim. So persistent volume claim will automatically provision persistent, the storage class will automatically provision the persistent volume. So let me first of all give you the idea how this all things are going to work. So I am using this kubesig. I am using this kubesig GitHub repository that is open, freely available, and all different repositories are available. About 179 repositories available for different Kubernetes related projects And if I search here NFS, so here is NFS subdirectory external provisioner. So this will automatically provision the NFS storage from NFS. It will create a directory inside the NFS share and will map to persistent volume, and then that persistent volume will be usable by persistent volume claim. So let me show you this NFS subdirectory project. Here is the documentation of Kubernetes NFS subdirectory external provisioner. There are different ways of deployment. So far, we have not discussed about Helm. We have not discussed about the customize. I will not give you the, I will not do the deployment like this. And if you go down, you can see here manually. So when you understand the manual, you will also understand the how the things are automatically working with the Helm. So NFS storage and manual ways described here, OpenShift, everything you can use. So let me go to this repository, and here you can see there is a directory deploy. And this is the complete, these are the complete manifest we are going to use to set up our storage class. So we will do a deployment, and this is the storage class deployment. And we will associate the role-based access control that will be used by the service account used in this deployment. And we have to set up the storage class. So we are going to use these three manifest. The rest of manifest are for the testing purpose. So first of all, I will show you this deployment. So this deployment, you can see the name is NFS client provisioner. And this deployment task is to automatically provision the persistent volume. And this magic will be done by the image, by this image, NFS subdirectory external provisioner. So this image is basically using these environment variables. And in these environment variables, we provide where is our NFS server, what is the IP, and NFS path, what share I want to use. So this image will automatically connect with this NFS server and will start provisioning the persistent volume. And this is the environment variable that will be pointing to our storage class. And here is a volume that is directly providing connecting with this NFS server. Mean this container is making sure that either this NFS is reachable or not. So if this NFS storage, if you remember, we did this exercise, that directly provisioning of NFS. So it is, this deployment is directly connecting with the NFS and trying to mount it here within the container. And inside the container with the name persistent volume. If this is done successfully, it's mean NFS server is up and running. So we can use this NFS server for provisioning. And here you can see the service account. So this service account will be used to perform all the actions on our NFS server. So, and only one pod will run under this provisioner, and this will be our deployment. Okay, so this will do the magic of PV creation. And if I go back before the deployment, what I need to implement this RPAC YM. So here you can see this is the manifest of creation of service account. And this is the NFS client provisioner service account creating under the default namespace. I will change this default namespace to some proper namespace for the storage class. And this will be used, I showed you in the deployment. And then there is a cluster level role is created. And name of this cluster level role is this NFS client provisioner runner. And these are all the rights that will be given to this role to perform different tasks on the cluster. Okay, just like events, it can see events, it can see the storage classes, it can see the persistent volume claims, get, list, watch, update. Uh, it can see the PV, and it can list the nodes, how many nodes it has. Okay, and then this cluster role binding is going to be associated with this user, uh, and here the you can see the role. This role is created with this storage class, with this service account. So if you are confused with this cluster role binding or role binding or what are the service account, go back to my previous videos in which I explain in detail the role-based access control. So, and then there is a namespace level of role that is performing these tasks endpoint level, and this is a namespace based binding. That was a cluster level binding. This is namespace level binding. So everything will be done automatically when we will just run this manifest. It will provision service account, cluster role binding, namespace level role, and namespace level role binding. Okay, next. Uh, After provisioning of these things, I have to apply the create a storage class. So storage class is a resource on the cluster level. So it will not come under some namespace. And here the storage class is using the same environment variable, whatever we have defined inside the deployment as provisioner name. Inside this deployment, I explained you. So I am quickly going to my setup, and here I will make a directory storage class NFS, and here storage class NFS. First of all, I will use this RBAC file, and I will do a complete copy this manifest, where I will create rbat.yml. Okay, so in this I will change the namespace. I will create some meaningful namespace, just like NFS storage class. So here, whatever resources are on namespace level, I need to provide this. Wherever the namespace is given. Role binding will be in the namespace, and namespace here I have to change. So we are done for this one. Let me quickly kubectl create namespace, and now I will do kubectl apply RBAC. So you can see all these resources are created. kubectl get service account in the namespace NFS provisioner, and if I just query a role, okay, and role binding, and cluster role binding. So cluster level of role binding, if I just, it's not a namespace level, if I just do a query to NFS based, so you can see the NFS client provisioner. This was created, and cluster role, this one is created. So everything is created by this RBAC. And now the next thing is I have to use this deployment. I have to use this deployment to deploy this NFS storage class, and it will be going under the namespace that I was using here, kubectl get namespace. And rest of all are good. We just need to change this with the IP of our NFS server that is reachable by all the nodes running in our cluster. So that we already done when we did the manual PV creation with NFS 159.110. And NFS path I will create. So let me quickly go to my NFS server. In this NFS server, get etc exports. So yes, this storage with this we can use if I go under the K8s and let me check all storage. So here something already created. Let me just delete this. Okay, so we can use this one. This path that is already exported in our NFS, and these will be reachable by all the nodes in our Kubernetes cluster. So let me just provide this path here, and under this path it will automatically provision the subdirectories. And here I have to provide the same NFS server. It is just for the testing purpose, as I explained you, for this deployment to make sure either NFS is up or not. And if this is not available, then this pod will not up and running. So if this is up and running, then your storage class will work. And this is a provisioner name, same provisioner name we have to provide inside our storage class. So this is done. I think everything is good. Let me just apply this file. So kubectl get pod -n this namespace. It is trying to create, and actually it is trying to create on worker node 2, and it is trying to pull the image. Yeah, it is up and running. Up and running mean it was able to successfully mount with the NFS. If our NFS is down, it will give you an error. You can test it by shut down your NFS server and then try to run this, restart this pod, it will not start. You can do the description of this pod, you can see whatever is mounted where. Okay, next is we have to deploy our engine is running that can help us to create the persistent volume. So now this is the class, storage class. So let me use this storage class. And this storage class is using the same provisioner. So we can have multiple storage classes. This storage class is pointing to NFS. We can have a storage class for elastic block storage for for Azure, for AWS, for Azure, for any cloud, whatever cloud is storage is providing. So we can have multiple storage classes. So for each backend storage technology set, there can be different storage classes. But so far we have only NFS. That's why we are using only one storage class. But remember, your cluster can have multiple storage classes that can point to that can provision for you different storages. So archive on delete false mean whenever we will delete persistent volume claim, it will automatically delete the persistent volume too. So if we set this to archive on delete true, so it will delete the persistent volume, but it will not delete, it will make a backup on the NFS server or whatever storage we are using on the backend. It will make a backup, archive that directory. So if I go to the documentation, I want to show you some storage class features. Like you can see here, this is provisioner name, they are giving storage account. Okay, there is a storage class where this storage class is directly pointing to NFS server. You can do also like this, but use this external storage provisioner. Storage class, there was a parameter I want to show you. Wait for first customer mean PV persistent volume will be attached automatically whenever this automatically be attached around the runtime. And there is volume expansion too. Means some storages on the cloud are expandable. So just like the block storage you can expand. You are provisioning in cloud. So that in that case, you can send allow expansion to true. And reclaim policy retain. Reclaim policy is retain mean whenever you are going to delete your persistent volume claim, it will not delete the persistent volume. It will retain, and whenever you will provision again the same persistent volume, it will automatically attach with that persistent volume claim, or at least your data will be safe. But if this is this value is delete, default value is delete. So here we have not set this value. It's mean the reclaim policy, it is set to delete. So whenever we will delete our PVC, it will automatically delete the associated PV. But you can set this to retain. Okay, so this was the option I want to show you. And the second thing, I for this to save the data whenever it will be deleted, I put the archiving true. It will create the archive. So far it is good. And kubectl apply -f class. I believe storage class is a parameter, updated parameter are forbidden. I believe I already have a storage class. STORE. Yes, it was. Let me just delete this one. I think I was doing some other exercises that was that time I create this. Let me delete this storage class. Let me apply this. So now if I show you kubectl get sc is a short form of the storage class. So you can see the reclaim policy is by default set to delete, whatever I showed you here. Reclaim policy by default set to delete, but you can set it to retain. And volume binding mod immediate, whenever someone will demand, it will automatically create the volume PV and will quickly bind it with the uh, uh, with with the persistent volume claim. And allow volume expansion is false by default. You can set it to true. And archiving we set to true. So if I do a kubectl describe storage class, the name of the storage class is NFS client. You can change this class name too. So here is default class no. Mean you can also set this to the default class. I will show you how what is the default class purpose. Archive on delete is true. Okay, so this is an important parameter, and allow expansion is not set, and reclaim policy is delete. Everything is done. Now we are done for our storage class, and we have one storage class that is NFS. Okay, and this attached with this provisioner, and this provisioner is actually the engine running inside kubectl get deployment -n in our namespace. This deployment and pod is associated with this provisioner. So this is the whole chain. I show you how this storage class is pointing to pod, and pod is then using a service account, and service account has a lot of role-based access controls to control, to automatically do the task, whatever you did so far for the persistent volume setup. Okay, now we are good. Now let me create this there is an example of test claim. Okay, so I will create a claim, persistent volume claim. We did this already, that's why I'm not spending time on this one. So if I go to my all YMLs, if you remember, we did PVC like this. Let me open this PVC. Let me check first of all kubectl get PV. We don't have any PV and PVC in whole namespaces. No, everything we deleted. I do a cat to this file, and here, okay, we can use this. I will just make a copy to PVC and PVC NFS test.yml. Here you can see its mod is read write many. So we discussed also this in detail when we did our PV and PVC as manual creation. So multiple pods can read this from multiple worker nodes at the same time. And this is mostly read write once in case of block storage device. And this is mostly read write once in case of stateful sets, because each database will have its own storage. So databases are not sharing storage with each other. Only stateless applications are sharing with each other. So if you are making this persistent volume for some unstructured data sharing, that will work for read write many, but for block storage based storage and for database based storage, it should be read write once. So I'm just making this read write many, and storage class name, is NFS client. So last time we have not provided this storage class name. we ask the cluster to create this resource, and we already provision the PV manually. But this time I'm just going to create 1 GB, and it will ask this storage class to provision the persistent volume. And name, I can say something like meaningful, sorry. kubectl get storage class NFS client. And here I will change NFS PV. Okay, test. In which namespace? Any namespace we can do, because this storage class is not namespace based resource at cluster level. So in the dev, I am going to create this PVC. Let me just apply this kubectl by-f PVC NFS test YML and kubectl get PVC-n dev namespace. So you can see this is created and bounded to. And if I show you the persistent volume, it is created with this name of 1 gigabyte read write many, whatever I define in my persistent volume claim, and reclaim policy is delete, mean whenever this will be deleted, persistent volume claim, it will delete the persistent volume too. And state is bounded, where it is bounded in the dev namespace with this PVC. And okay, so this is created. And if I go to my NFS, here I list down, you can see dev NFS PVC test. This directory is just right now created. And whatever now this persistent volume claim I can attach with any pod, that I will not do. But here is an example test pod. Here it is using this whatever NFS PVC you created, you can associate with your pod and you can test it. But I will not do this because you can follow the video that I did for the very first session for the persistent volume and persistent volume claim. So just test this one. You can attach this persistent volume claim with multiple pod, and all the pods can see the same data. Okay, so this was the way we can set up the multiple persistent volume automatically. So now whatever load will come, you don't need to worry about the persistent volume creation. So let me just quickly modify this one with the dev namespace read write, for example, once. Okay, again, for example, 5 GB, and if from the same name class. Okay, let me just apply this kubectl apply FNF. So kubectl get PV. It is created of 5 GB, and PVC in the dev namespace. It is created bounded. If I go to my NFS, second directory is automatically created. Okay, and now if I don't want to use some PVC, just like this test in the dev namespace, let's see what happens. So get PVC, you can see it's deleted. And if I get persistent volume also deleted. But what happened to that directory? It is preserved, but archived, just it renamed. to archived, and rest of all name is same. So it's mean we can restore our data even if we delete mistakenly our persistent volume and persistent volume claim. Or you can use this way to reclaim policy, mean don't delete the PV. So this was the storage class session. I hope you got the idea. If you have any questions, you can write me email. I can reply you. And I will in the video description, I will provide this link. You can follow. And in our next session, we are going to run the ingress controller. What is the concept? How in professional life you will host your application and by name and SSL certificate, offloading, everything, how that is working. So far, we are good for this session. So in the next session, we will continue ingress controller.